There is a part inside an engine block that costs less than a cup of coffee. It is a small cylinder of hardened steel, no springs, no hydraulics, no electronics. And in the right engine, it will outlast every other moving component by 100,000 miles or more. Manufacturers knew this. They tested it, they documented it, and then slowly, quietly, they engineered it out of production. Not because it failed, because it worked too well. When a $5 part means an engine never needs a major valve train repair, that is a problem for the people selling parts. So they replaced it with something more complex, more fragile, and far more profitable. Most enthusiasts today have never even held one. They do not know what it looks like. They do not know why it disappeared. But by the end of this video, you will. And it will change the way you look at every engine you touch from here on out. That part is the solid mechanical lifter. Some people call it a solid tappet. Others call it a flat tappet. But the correct name does not matter nearly as much as what it does and why the industry wanted it gone. To understand this, you need to understand what a lifter actually does inside your engine. It sits between the camshaft and the pushrod. Every time the camshaft spins, a lobe pushes against the lifter, and the lifter transfers that motion up through the pushrod, into the rocker arm, and down onto the valve. That is how your engine breathes. The lifter is the messenger. It carries the signal from the cam to the valve, thousands of times per minute at extremely high pressure and speed. Now a solid lifter is exactly what it sounds like. It is a solid piece of steel. There are no internal moving parts, no oil passages running through it, no tiny piston or spring hidden inside. It is just metal meeting metal with a precisely machined surface. And because there is nothing inside it to wear out, break down, or lose pressure, it lasts almost indefinitely. The only maintenance it requires is a periodic valve lash adjustment. That means every 20 or 30,000 miles, you slide a feeler gauge between the rocker arm and the valve stem, and you set a small gap. That gap is what allows the valve to close fully when it is supposed to. The whole job takes about 45 minutes if you know what you are doing, and maybe an hour and a half if you are learning. No special tools, no computer, no scan tool, just a wrench and a feeler gauge that costs $3 at any parts store. That is it. That is the entire maintenance requirement for a part that can run for 300, 400, even 500,000 miles. There are documented cases of commercial truck engines running solid lifters past 1,000,000 miles with nothing more than regular oil changes and occasional lash adjustments. Think about that for a moment. A $5 part, a 45-minute maintenance interval, and an engine that refuses to quit. So why would any manufacturer walk away from that? Why would they replace something that's simple, that reliable, that cheap, with something more complicated? The answer is not engineering. The answer is economics. In the late 1960s and into the 70s, automakers began shifting to hydraulic lifters. A hydraulic lifter looks similar on the outside, but inside it has a small piston, a check valve, an internal spring, and a tiny oil passage. It uses engine oil pressure to automatically take up the slack in the valve train. That means no more lash adjustments, no more feeler gauge. The engine is quieter right out of the box because there is no gap to create a ticking sound, and the customer never has to think about it. That sounds like progress, and on paper, for the first 50,000 miles it is. But here is what they did not put in the brochure. Hydraulic lifters are sensitive to oil quality. They are sensitive to oil pressure. They are sensitive to contamination, heat cycling, and age. Over time, the tiny check valve inside the lifter starts to wear. The internal spring loses tension. The small oil passages get clogged with sludge or varnish. And when a hydraulic lifter fails, it does not just tick. It collapses. When it collapses, the valve does not open fully or does not open at all. You lose compression on that cylinder. You lose power. You get a misfire. And in some engines, if the lifter collapses at the wrong time, it can cause the valve to contact the piston. That is a bent valve. That is a cylinder head coming off. That is a repair bill measured in thousands of dollars, all because a small internal spring inside a lifter gave up after 80,000 miles. Meanwhile, the solid lifter that was sitting in that same spot 20 years earlier would have just kept going. No collapse, no failure mode. Just a quiet, predictable, manageable ticking sound that tells you the lash is a little wide, and it is time for a 5-minute adjustment. The switch to hydraulic lifters was sold to the public as a convenience feature, and it was convenient for the dealership service department, because now, instead of a shade tree mechanic adjusting his own valves in the driveway for free, you had a customer coming back to the dealer every 60 or 70,000 miles for lifter replacement, cam inspection, and valve train work that could run $500 to $1,500 depending on the engine. Multiply that across millions of vehicles, and you start to see the math. A $5 part that never fails does not generate service revenue. A $40 part that fails predictably generates a fortune. And this is not conspiracy. This is documented. Engineers at Chrysler, Ford, and General Motors all wrote internal memos during this transition period, acknowledging that solid lifters had superior longevity. The concern was not performance. The concern was what they called customer complaint levels, which was code for the ticking sound. Customers in the late 60s were used to smooth, quiet engines. The small ticking of a properly adjusted solid lifter became a warranty claim, not because anything was wrong, because the customer did not understand that the sound was normal. Rather than educate the customer, the manufacturers chose to eliminate the sound by eliminating the part. And in doing so, they eliminated one of the most durable, most cost-effective components an internal combustion engine has ever used. Now, if you are watching this and you are starting to feel a slow burn in your chest, good. Because this is the kind of information that separates someone who buys cars from someone who understands them. And if you appreciate that difference, take a second and hit the subscribe button. This channel is built for people who want to think like engineers, not like shoppers. We do not chase hype, we chase durability. Let me tell you where this matters most. If you are shopping for a classic car or a project vehicle right now, and you are looking at engines from the mid-1950s through the late 60s, you are looking at the golden era of solid lifter design. These engines were built during a time when parts were expected to last because the manufacturer's reputation depended on it. There was no extended warranty program. There was no prepaid maintenance package. If your engine died at 60,000 miles, you told your neighbors and they bought the other brand. So these companies built engines to survive. One of the finest examples of this philosophy is the Chrysler Slant 6, the 225 cubic inch inline six that Chrysler introduced in 1960. This engine used solid lifters from the factory. It had a cast iron block, a cast iron head, and a valve train so simple that a teenager could rebuild it on a workbench. The Slant 6 earned its name from the way the engine was tilted 30 degrees to one side in the engine bay, which lowered the hood line and improved the center of gravity. But the real genius was not the angle, it was the internals. That engine had 7 main bearings on the crankshaft. Most 6-cylinder engines of that era had 4. 7 main bearings means the crankshaft is supported at more points, which means less flex, less vibration, and dramatically less wear. Pair that with solid lifters that never fail, and you get an engine that routinely ran past 300,000 miles. In taxi cabs, delivery trucks, and police cars, with nothing more than oil changes and the occasional valve adjustment, these engines are still out there. You can find a running Slant 6 in a Dodge Dart or a Plymouth Valiant for under $3,000 in many markets right now. And most buyers skip right past them because they are not glamorous. They are not big block muscle. They are not numbers matching collectibles. But they are the cockroach of the engine world. They survive everything. And the $5 lifters inside them are a big reason why. Another engine that followed this same philosophy is the Ford 300 cubic inch inline six. This was Ford's workhorse from 1965 all the way through 1996. Over 30 years of production. It powered the F-Series trucks that built America's suburbs and hauled its freight. And in its earlier configurations, it ran solid lifters. The 306 had a similar design philosophy to the Slant 6, a long-stroke, low-revving, high-torque engine designed to be loaded hard and run forever. Truck drivers who maintained them properly reported 400,000 miles before the first internal engine work. Not a rebuild, not a top-end job, just the first time anyone had to open the engine up at all. The reason was the same: solid lifters, simple valve train, predictable maintenance, and an engine block that was cast so thick you could bore it out 3 times and still have cylinder walls strong enough to handle full load. These trucks are criminally undervalued right now. A 1978 F-250 with a 306 and a 4-speed manual is one of the best mechanical investments you can make if you are interested in a vehicle that will run for decades with hand tools and basic knowledge. And most of the market is ignoring it because it does not have a VATE badge. The Chevrolet 235 cubic inch inline six is another one that deserves serious attention. This is the engine that powered everything General Motors made from 1941 through 1962. Over 20 years of continuous production. It ran solid lifters for its entire lifespan. The Stovebolt 6, as it was called, had a reputation for being unkillable. It was not fast. It was not flashy. But it started every morning, pulled its weight every afternoon, and asked for almost nothing in return. You can still find these engines in old Chevy trucks, farm equipment, and industrial applications, running on original lifters that have never been replaced. 60, 70, 80 years old. Same lifters, still working. $5 worth of hardened steel doing what it was designed to do before anyone decided that replacement revenue was more important than reliability. And this pattern, this quiet disappearance of indestructible parts, did not stop with lifters. It happened across the entire engine. Take the oil bath air cleaner. Before paper air filters existed, most engines used a canister filled with oil. Air came in through the top, was forced down into the oil bath where dirt and dust stuck to the surface of the oil, and the clean air passed through a mesh screen and into the carburetor. The oil bath air cleaner lasted forever. You never replaced it. You just drained the dirty oil out every few months, wiped the canister clean, poured in fresh oil, and bolted it back on. The total cost of maintenance was about 20 cents worth of motor oil, and it filtered air more effectively than early paper filters, especially in dusty conditions. Farmers, ranchers, and military operators swore by them. Paper filters replaced oil bath air cleaners, not because they filtered better. Early paper filters actually filtered worse in heavy dust, but because they were disposable. A disposable filter means a recurring purchase. Every 3 to 6 months, the customer walks into the parts store, buys a new filter, throws the old one away, and comes back again next season. That is annuity revenue for the filter companies. The oil bath cleaner generated 0 repeat sales. It just sat there, doing its job decade after decade, so it had to go. If you are restoring a classic vehicle and it came with an oil bath air cleaner originally, consider keeping it or finding one. They work, they are cheap, and they connect you to a time when parts were designed to serve the owner, not the parts counter. The same thing happened with mechanical fuel pumps. A mechanical fuel pump is a simple device bolted to the side of the engine block. It is driven by a small lobe on the camshaft. Inside, there is a rubber diaphragm that flexes back and forth, drawing fuel from the tank and pushing it to the carburetor. The whole unit has maybe 6 moving parts. It costs $10 to $15 to rebuild with a kit that includes a new diaphragm, a spring, and a set of check valves. And it will run for 100,000 miles or more between rebuilds. Electric fuel pumps, which became standard starting in the late 1970s and early 80s sit inside the fuel tank. They are submerged in gasoline. They run constantly whenever the engine is on. They generate heat. They are sensitive to fuel quality, ethanol content, and voltage drops. And when they fail, which they do, usually between 60 and 100,000 miles, the repair involves dropping the fuel tank, disconnecting multiple lines, removing the pump assembly, and replacing it with a unit that costs between $200 and $500. On some modern vehicles, the fuel pump is integrated with the fuel level sender, the fuel filter, and the pressure regulator, making it a single module that can cost over $1,000. To replace, the mechanical fuel pump did the same job for $10 with a screwdriver and 20 minutes, but it did not generate the service revenue that a failed electric pump generates, so it was replaced. Not improved, replaced. If you appreciate this kind of thinking, this way of cutting through the marketing, and understanding what actually makes an engine last, then drop a comment below. Tell me what engine you have run the longest and what you think made it survive. I read every comment, and the conversations on this channel are some of the best on the platform because the people here actually care about what is under the hood. Now, let me take this one step further, because the solid lifter story connects to something even bigger that most people never think about. The reason a solid lifter lasts so long is not just that it is simple. It is that it operates on a principle that the modern automotive industry has almost completely abandoned. That principle is adjustability. A solid lifter system is adjustable. You can set the clearance. You can chain it. You can fine-tune it for different operating conditions, different fuels, different altitudes. If you are running an engine hard in the summer heat, you can open the lash up slightly to compensate for thermal expansion. If you are running in cold weather, you can tighten it. The engine talks to you through that lash setting. A mechanic who understands valve lash can diagnose wear patterns, predict failures, and extend the life of an engine just by listening and measuring. Hydraulic lifters took that away. They are self-adjusting, which sounds like a feature, but it means you have no input. You cannot read the engine through the lifters anymore. You cannot compensate. You cannot fine-tune. You just wait for the system to fail and then you react. That shift from proactive maintenance to reactive repair is the single most profitable change the automotive industry ever made. It turned skilled owners into dependent customers, and it turned $5 parts into $500 problems. This same philosophy of adjustability existed in other components that have since disappeared. Adjustable rocker arms, for example. In a solid lifter engine, the rocker arm typically has an adjusting nut or screw that allows you to set the valve lash precisely. This means you can compensate for wear over time. If the valve seat recedes slightly after 100,000 miles, you adjust the lash to match. If the pushrod wears 1/1000th of an inch, you adjust. The engine stays in tune because you have the ability to keep it there. Modern engines with hydraulic lifters and non-adjustable rocker arms offer no such option. When wear occurs, the only fix is replacement. Bronze valve guides are another example of a component that was quietly phased out for economic reasons. Older engines, particularly those built through the 1950s and 60s, used phosphor bronze valve guides. Bronze is softer than cast iron, which sounds like a disadvantage until you understand what it actually does. A bronze guide provides a self-lubricating surface for the valve stem. It resists galling, which is when two metal surfaces weld together under heat and friction. It dissipates heat more efficiently than cast iron. And when it does eventually wear, it wears in a uniform, predictable pattern that can be corrected with a simple reaming and the installation of a slightly oversized valve stem. Repair cost is minimal. The guide itself lasts 150,000 miles or more under normal conditions. Cast iron guides, which became the standard in later engines, are harder, but they wear in irregular patterns. They create hot spots. They do not self-lubricate as effectively. And when they wear, the repair is often more invasive, pressing out the old guide, pressing in a new one, and remachining the seat. The labor is more. The parts cost more. And the failure happens sooner. Bronze was better. It was cheaper in the long run. But it did not create the service cycle that iron guides created, so it faded away. There is a direct line between all of these examples. Solid lifters, oil bath air cleaners, mechanical fuel pumps, adjustable rocker arms, bronze valve guides. Each one was a simple, inexpensive, long-lasting component that gave the vehicle owner control over their own machine. And each one was replaced by something more complex, more failure-prone, and more profitable for the manufacturer and the parts supply chain. This is not about nostalgia. This is not about pretending the old days were perfect. Plenty of things about old cars were terrible. Drum brakes were worse than discs. Points ignition was worse than electronic. Bias ply tires were worse than radials. Real engineering improvements happened, and we should celebrate them. But the lifter swap was not one of those improvements. The death of the oil bath air cleaner was not an improvement. The burial of the mechanical fuel pump was not an improvement. Those were business decisions dressed up as progress. And here is why this matters to you right now today. Whether you are building a project car, restoring a classic, or just trying to keep a daily driver alive on a tight budget. If you understand which parts were designed to last and which parts were designed to be replaced, you can make smarter decisions at every stage of ownership. You can choose engines that use solid lifters and gain a valve train that will outlast the chassis it sits in. You can source oil bath air cleaners for pennies at swap meets and never buy another paper filter. You can rebuild a mechanical fuel pump in your garage for $10 instead of paying a shop $500 to drop your tank. Knowledge is the cheapest upgrade you will ever install. And the information in this video is the kind of knowledge that used to get passed down from father to son in the shop, from mentor to apprentice on the shop floor. It was never written in a manual, because the people who knew it did not need a manual. They learned it by running these engines for decades and watching what survived and what did not. The classic car market right now is obsessed with numbers matching, original paint, celebrity provenance, and auction theater. And if that is your world, more power to you. But underneath all of that, the cars that will still be running 50 years from now are not the ones with the prettiest paint. They are the ones with the simplest, most durable internals. The ones with the $5 parts that no one thought to engineer out of existence. The ones that were too cheap to break in, too tough to quit. If you are looking for your next project, stop scrolling through listings based on body style and start looking at what is inside the engine. Find out if it runs. Solid lifters. Find out if it has adjustable rockers. Find out if the valve guides are bronze. Find out if the fuel delivery is mechanical. Those are the markers of an engine that was built to last, not built to be serviced. And those are the engines that will still be starting on cold mornings long after the complicated, over-engineered alternatives have been scrapped for core charges. The automotive industry hid the $5 part, not in a vault, not behind a locked door. They hid it in plain sight by convincing 2 generations of car owners that simpler meant worse and that automatic meant better. They replaced your ability to maintain your own engine, the system that requires their tools, their parts, and their labor rates. And most people never questioned it because the new engines were quieter and the old ticking sound was gone. But that ticking sound was not a flaw, it was a heartbeat. It was the sound of an engine breathing through a valve train that you controlled, that you maintained, and that would never let you down as long as you gave it 45 minutes and a feeler gauge. Now you know. So the next time you pop a hood and you hear that faint, rhythmic tick from the top end, do not walk away. Lean in. That is the sound of a $5 part doing a job that nothing more expensive has ever done better. That is the sound of an engine that was built for the person who turns the wrenches, not the person who writes the invoices. And that is the sound of your next project. If you are smart enough to hear it, go find one. And when you do, come back and tell me about it. This channel is built for people who fix what they find, who learn what they drive, and who refuse to pay more for less just because someone in a boardroom decided that forever was bad for business. I will see you in the next one.